All right, on to the next. So we're going to do something called pressure volume loops. And this is tied back into stroke volume. Okay, so we've kind of hit most of these objectives, but now we're going to tie them together with preload and afterload. So we've talked about preload, haven't talked about afterload, but we'll get to that. Okay, now we have these figures here, and it's important to know there's no time component, but we've got ventricular volume on the x-axis, and we've got pressure on the y-axis. And time goes this way. It's a cycle. Okay, each of these segments represents one phase of the cardiac cycle. So A is filling, B is isovolumic contraction, C is ejection, and D is isovolumic relaxation. Okay, and so just to show you, A, we have a slight increase in pressure, but a huge increase in volume. B, volume remains constant, but pressure goes up. C, volume goes down the entire time, but pressure goes up due to contraction, and then it reduces due to loss of blood or the ejection of blood. And then D, we have constant volume, but we're losing pressure as the ventricle relaxes. Okay, and then stroke volume is just the difference between these two segments, okay, between our highest volume and our lowest volume. That's stroke volume. Okay, so we want to increase preload. How is this going to change this figure? So remember, what does preload correspond to? And preload corresponds to end diastolic volume, and this is end diastolic volume here. Okay, and so if we increase preload, we're increasing the amount of blood in the heart, in the ventricle before contraction. And so what does that do to end diastolic volume, end systolic volume, and stroke volume? Well, as you can see, and I just mentioned, end diastolic volume increases. Okay, so it goes from here to here. End systolic volume stays the same, but because I increase end diastolic with end systolic staying the same, stroke volume increases. All right, so let's do this again, but this time let's decrease preload. So in this case, end diastolic volume is going to go this way. Okay, my pressure won't be as great because I'm not ejecting as much blood. And so we have a lower end diastolic volume. Again, end systolic volume is not affected by preload, so that remains constant. But as a result, because end diastolic volume gets smaller, my stroke volume also gets smaller. So remember, preload is end diastolic volume. No real effect on end systolic volume, but it has a big effect on end diastolic volume. So what is afterload? Okay, so kind of a technical definition is afterload is the load against which the ventricular contractile force works to open the semilunar valve and eject blood. Okay, in other words, to put it simpler, afterload is just the pressure the ventricle has to overcome to eject blood. Okay? In other words, it's aortic pressure. Okay? The valves don't open in the ventricles until we exceed aortic pressure. When ventricular pressure exceeds aortic pressure, we have ejection. And so notice ejection goes, and this box is the length of the time of ejection, but it goes from, here we go, so it goes from here all the way to here. If I could draw straight lines, that would be great. Okay, so what's going to happen if I increase afterload on this graph? Another thing that I want you to consider is what's going to happen to ejection time if afterload increases. All right, and so you're only going to change one of these curves, so which one is it? Well, since afterload corresponds to aortic pressure, you're going to change the black line. Okay, and if I'm going to increase afterload, that means I'm going to increase aortic pressure, so it's going to look something like this. Okay, now what has happened to ejection time? Well, it's gotten shorter because it's going to take longer for us to open up that semilunar valve, but then that semilunar valve is going to close earlier. Okay, and so my ejection time is reduced. So let's bring this back to the pressure volume loop. We're only going to increase afterload. We're not going to mess with decreasing afterload. So what's going to happen to this curve if I increase afterload? Well, remember, it doesn't really do anything to end diastolic volume. This is only going to affect end systolic volume, or how much blood's leaving the heart. So if I increase afterload, less blood's getting out of my heart, so there's going to be more left in it at the end of contraction. So end diastolic volume stays the same, and systolic volume increases. As a result, I have decreased stroke volume. So to summarize, preload is the stretch that's in the ventricle prior to contraction. In the cardiovascular system, we're talking about the ventricle. Okay, and so this is due to end diastolic volume, or the amount of blood in the ventricle before contraction. Afterload is the load that the muscle has to contract against to do its thing. In the cardiovascular system, that's the pressure in the aorta. The ventricle has to generate enough pressure such that it exceeds aortic pressure, and we can open up that semilunar valve. Okay, as long as the pressure in the ventricle is greater than the pressure in the aorta, the valve is open and blood is ejected out of the heart. And so that is a basic overview of preload and afterload.